So this is what I'll be talking about. Why Starknet, why Cairo, Starknet architecture overview, universal deployer. And yeah, so why Starknet? Starknet is a layer 2 network that makes Ethereum and recently, very recently, Bitcoin transactions faster, cheaper, and more secure using ZK Stacks technology. So um, before this week, it was only on Ethereum. It was a boosted layer on Ethereum, but luckily, with the whole work that has been put in place, we now at Starknet, we can now help Bitcoin make their transactions faster and more secure than it actually was before. The technology backing Starknet is ZK Stacks technology to bundle transactions and speed up these transactions, reducing the throughput, reducing network congestion, and increasing the numbers of transactions that get finalized within a very, very short time. All right, so why Starknet? Starknet, because it solves the layer 1 scaling problem. Also, it uses the validity proof to prove that these transactions that are being bundled by the sequencer and sent are all verified and are correct before sending them to the verifier on the L1 smart contract. It uses Stack technology, ZK Stack technology, and not ZK Snacks. It is optimized for ZK Tech. It has a powerful programming language, which is called Cairo, which is very, very close to Rust, almost 90%, 95% correctly like Rust. It's also, you can withdraw your asset in less than 10 hours on layer 1 from Starknet, and you don't need a trusted setup because it utilizes the ZK Stack technology. All right, let's talk a bit about Cairo. What is Cairo? So Cairo is a programming language that helps us write provable programs. It runs on its own VM called the Cairo VM, and its syntax is Rust inspired. With Cairo, you can write your programs outside of Starknet, building just programs. But when you're writing smart contracts, it is just supported by Starknet. It uses the ZK text and it verifies without re-execution, which was the previous L1 problem, where for any node for any block proposer to propose a block, every node need to re-verify the transactions in that particular block, which is very cumbersome, takes so much time to do. But with this, all these transactions are just sent into a proof. You just need to verify the proof, which is way, way less time than verifying all the transactions in the block. So it verifies without re-execution and prevents cheating and malfunctions. So a little bit about the Starknet architecture. Starknet operations begins when a transaction is received by a gateway. So what I'm trying to explain here is how do you get involved? How do you start transacting? How do you start acting, doing something on the Starknet network? You start first by having a transaction done. Once that transaction is done, what happens behind the scene is to you, as a user, you can just have your wallet, argent or braavos, and then you send some funds from your wallet to another wallet, and that's all for you. But behind the scene, what happens is that that transaction you sent is stored in a short-term memory called the memory pool, where these transactions from you, from me, from every other person that would be carried out from by the sequencer, bundled together. Each transaction firstly would be executed and verified before being bundled into the proof, and then the sequencer incorporates the transaction into the network state. And at this point, once the transaction has been bundled into that proof and sent to the prover, you, the user, what you would see in the transaction history or the scan, you would see that the transaction has been accepted on L2. So the next thing is, after it has been sent to the prover executes the whole proof, calculates the proof, and submits it to layer 1. Layer 1 means the smart contract for Starknet that has been deployed to the layer 1. It is a verifier contract, and every proof that holds the bundled transactions from Starknet are sent to that verifier. And after the verifier verifies that proof, then the transaction reaches finality. So this only affects you if you're trying to spend your assets, your tokens from Starknet in a layer 1 like Ethereum. But if you're just doing a normal transaction on Starknet to Starknet transaction, this doesn't affect you. You just see your transaction is gone immediately. But if you want to receive your funds into an Ethereum account or not the Bitcoin account, you'd have to, this transaction has to be verified by the verifier. The proof generated with the execution trace needs to be verified with by the smart contract verifier in the layer 1 ecosystem. And after that, it can be sent to the data availability layer, where when you want to do your DApp, integrate your front end, you can fetch data from the already deployed smart contracts. Sorry, I'm rushing. I hope you're getting some points from this. So these are some key components in the Starknet network: the sequencer that validates, executes, and bundles transactions into blocks. Sharp is, it generates validity proof for Starknet and Starkest. Sharp is the prover that generates this validity proofs that is sent to the L1. The verifier is an L1 smart contract that verifies the proof sent from the Sharp prover. Starknet Core is the data availability layer 1 smart contract that stores changes to the global state. So once the transaction, after the prover sends this transaction to the verifier on layer 1 and it gets verified, the next thing is that this information changes the state of Starknet on layer 1, and then this information is stored in the data availability layer for the Starknet core. Then the full node provides DApp with blockchain data from DA. And you can see some services like Ethers.js, Web3.js. They are like pathways that give you access to the Starknet core, where you can read information and write information to the smart contract already deployed. Yeah, so these are the nodes, the Starknet nodes. On the L2, that's the Starknet itself, we have the sequencer, the prover, and the full nodes. And on L1, we have the verifier and the data availability layer, the Starknet core. And for Starknet transactions, for every Starknet smart contract that you write using Cairo, you first declare the transaction. Declaration helps you to deploy the class hash for that transaction, and then deploying helps you to deploy an instance of that class hash. And to deploy, we have something called the universal deployer. The universal deployer is also a smart contract that sole purpose is for deploying smart contracts on the Starknet ecosystem. It has only one function signature called deploy contract. So anytime you click, you write the command in the CLI to deploy your smart contract, you are indirectly calling this universal deployer. You're calling the deploy contract function. You're triggering the function to deploy your smart contract for you. And these are the various transaction types we have on Starknet ecosystem. The deploy account, where you have to deploy your accounts, either it's argent or braavos. And what I mean by account, I mean your wallet, address. For every address you have on Starknet is a smart contract account. It is not an EOA, externally owned account. It is a smart contract account, and you have to deploy it. If you don't deploy it, the account won't, the wallet address will not be used. Also, we have declare. Declare is the function signature, is the opcode for declaring the class hash, the serial code of your smart contract. Invoke helps you to write to your smart contract that you've already deployed. So when you see an invoke opcode on the Starknet scan, it means that the user performed a write function that is supposed to change the state of that smart contract on the network. Call is not a transaction type, as it is only used as read only. It is only used to read transactions that have already been stored on the blockchain. All right, that being said, I think we should go into Cairo, but I want to give room for any confusion to clear the air. Any questions? Any confusion? Okay, so I think, is this the only question? Okay, I think this is the only question. So, what's the time it takes for the sequencer getting a transaction to the verifier, checking the new block on L1? So it doesn't take so much time. Once you execute a new transaction, if you pay attention to the scan, you see that it takes a few seconds for the transaction to get picked up by the sequencer from the main pool. It gets picked up and then gets bundled into one, the various transactions sent, and then gets sent to the prover. So upon the time where the transaction is sent to the mempool, gets bundled up and sent to the prover, it takes based on my own experience, a maximum of 1 minute, but it can be as fast as 5 seconds to 10 seconds. But the slowest I've experienced was a maximum of 1 minute. If that is what you mean, yes, thank you. Okay, thank you. All right, so let's go deep dive into Cairo programming language. So firstly, if you haven't worked with Cairo before, I would advise you to go through the Cairo book. I'll be dropping the link also, so you can get yourself your system set up. You need to install Rust in your system. You also need to install Scab. So you need to have your setup, but I cannot do those installations in this call, but we can meet in the Telegram. So sorry, not this. Yes, book.cairolang.org. It will help you get set up, where you have to install Scab and all that. So please go through this so you can get yourself set up. I'll be dropping the link here, maybe for those who just want to pick it. Cool. All right, so I'll be initializing a new Cairo project now. Please let me know if you can see my screen. Is this okay? Can just thumbs up. Okay, thank you. All right, so I start afresh. Once you have Rust installed and you have your scab installed, scab is a package manager for Cairo, just like when you're working with Rust, you work with Cargo as a manager for Rust. So we use scab for Cairo. So to set up a new project, I just do this scab new build her, and then we can open this up. Okay, so just to walk you through. Once it's set up, you have your scab.toml that holds all the dependencies, the versions that you of the packages you'll be using in your program, in your application. Here, you have your git ignore, and you have your src. The src holds the lib.cairo and every other Cairo program you'd love to write. So you can create a new folder just like this, .cairo, and you're good to go with this. All right. So for every Cairo project, for every Cairo program, for every Cairo program, you you need to have a main function before it gets executed. There must be a main function in that program. And yes, I think that is the most important thing I want to tell you here. All right, let's proceed. Okay, so I'm going to write my name and the time, I think, that you started with Cairo. You start with FN, meaning function. The next thing is the function name. You should be used to this from your normal programming languages that you're comfortable with. So I just want to print my name, and this is the command to print this to your console, and the ln to print it on a new line. So my name is Faith Robert. Cool. And then I come to main. Here we have a question. Oh, thank you. Thank you so much. Okay, so we come to the main, and then we call name. And then the next thing we do is we try to run this to see if it works. And you run this using the command scab Cairo run. And then it compiles. And after compiling, it runs, and then it returns my name is Faith Roberts. And then the next, I go with it. date. And I want to show you the different ways you can write a functions in Cairo programs. So this is a function without a parameter. So this function doesn't expect an argument. While this, I'll be making this a function with a parameter. So it expects an argument. And just similar to Rust and any typed language, once you declare a variable, you are expected to declare its data type. That helps you understand the type of values that particular variable is meant to have. So for the date, I'm just going to write it there as a unit 8. It can be more than that if you're working with epoch time and stuff. So I can say let's, okay, no, there's no need for this. Let me just print. Say the date is June 2024, and I pass X. Or I can use this method where I say the date is, and I put passing X here without, and take this off. The both methods should work. And then I come here, the main, and I call dates. And then I pass 8 as the argument. So to run this, I'll just do scarp Cairo run, and you can see it returns my name is Faith Roberts. The date is 8th June 2024 for this. And for this, it returns the date is 8th June 2024. And so we can do all manner of things. You can write various implementations, various logics, depending on what you're trying to build. But I don't want to bore you with it. I just want to show you how the folder structure is and how to go ahead writing your first Cairo program, your Hello World in Introduction to Cairo. And so I'll be introducing you to something called Starklinks. So Starklinks is an application that helps us learn Cairo, fast track our learning with Cairo, and make us good to go at the end of Starklinks. We can start making some meaningful contributions to Cairo projects or Starknet projects. And so I'll be going to Starklinks. We are going to do some of the tasks on Starklinks, maybe up to 10. And then I expect from here, you can go and complete the challenge of Starklinks yourself and become Cairo experts. How is that with us? Okay, cool. Thank you so much. So here's the link for Starklinks. Starklinks now have a web version, which makes everything a whole lot better. Starklinks.app. All right, great. And I'll drop this in the chat also. So you can go to starklinks.app You can go ahead to connect your GitHub repo. Connecting your GitHub repo helps you to keep track of your progress, but I won't be doing that. I've done this a couple of times, and if I do that, I won't get this fresh page. I would have to continue from where I stopped. Yeah, so let's start coding. Now skip this. And yeah, so okay, here. Okay, cool. Let me see. Okay, cool. So let's start from the first one. All right. So I just want to be sure we are all on the same page. Are we ready for the start links? Okay. It's just one person. Please hope I'm audible enough and you understand what I'm saying, right? Okay, thank you. Thank you so much. Thank you so much. All right, so let's start with Starklinks. Welcome to Starklinks, Cairo version 1. This exercise doesn't do anything yet, but it still compiles. Cairo file getting run needs to have a main function. So this file is a valid Cairo file. Other exercises will require you to write Cairo code to make the exercise file compile. So what this means is that we have a main function, and so this is going to compile. Even though we don't have other implementations, but this can be seen as a valid Cairo program because it has the main function and it will compile. And when we click on compile, it should compile. And we can see, great, the submitted code compiles perfectly. Click next whenever you are ready to proceed. And that is how it is for the entire Starklinks challenge. And we have a lot of challenges, that will make you a Cairo expert at the end if you can complete it. So let's go to 2. So this exercise won't compile. Can you make it compile? If you can check here, for a Cairo program to be valid, it needs to have a main function. So we need to add a main function, even though our main function does nothing, or if it does something, it's good. So it says, make me compile. And this is the main function, and it says x is equal to 5, print line on the new line, x is 5. So this is not going to compile because x has not been declared anywhere before. And to solve this problem, we just need to add the let keyword, and that should be good to go. Good. And then we come to 2, and it says let x, it declares x, and it says if x is directly equal to 10, print x is 10, else print x is not 10. This is not going to compile because in Cairo code, you cannot define a variable without assigning that variable a value. And so this would not compile. You have to assign a value to x before this will compile. So we can say x is equal to 1, compile, and we are good to go. I go to the third one. Same thing, but the difference here is this x has a type called felt252. Even though it has a type called felt252, this is just the data type x is expecting. You haven't assigned any value to X at this point yet. So you need to assign a value to X. Let's say 2. Oh, sorry. And then we compile. And great. And here it says, let X be equal to 3. Print X is 3. And here it says X is equal to 5. Print X is now 5. And don't change this line. So what's going on here is that we're trying to change the value of X from a previous value to a new value. With your normal JavaScript programming language, I think this is good to go. But here, this would not work because every variable in Cairo has a constant attribute. And so every variable declared in Cairo is immutable by nature. All variables are immutable. So to make it a mutable variable where you can change the values, you need to add the mute keyword. And then it makes this mutable. Now, there are different ways you can solve this, but seeing this particular instruction, don't change this line, the only thing you can do is to make sure X is a mutable variable where you can keep on changing the values assigned to X at different intervals. So if we compile, this should run. And yes, it has. So going to this, I think this is the 7th one. It shows, make me compile. Let number be 1 and print number is 1 and says don't change this line. And here it says number is equal to 3 and it says don't rename this variable. And because this don't change this line is actually stated here, what it means is that we are trying to do variable shadowing. So we're trying to shadow this particular variable with this. And so what we need to do is to add the let keyword. Going to the 8th, make me compile. Now in Cairo, when you have a constant, a variable that is a constant, that you're storing as a constant, you start with the keyword const and the variable, the naming convention for the variable has to be in uppercase. And also, anytime you declare a constant variable, you need to assign its type immediately. You cannot declare a constant variable without assigning the data type of that variable. So this is not going to compile because it doesn't have a data type assigned to the variable name. Although the small number has a data type called uint8, it doesn't matter, it still won't compile because this variable needs to be assigned a data type. So let's compile first so you see the errors. Something wrong with your code, failed to compile. Unexpected token, it expected this colon followed by a type. Const number is equal to 3. also const small number is equal to 3. So let's assign it unit 8, unit 8. Sorry, I keep on pressing save on my system. I'm forgetting this is the web version. When we compile this, we say great. And then we go to the ninth one, primitive types. It said fill in the rest of the line that has code missing. No hints, there's no tricks, just get used to typing this. Okay, so this is the code. Let is morning be equal to true. If is morning, print good morning. And then it says, let finish the rest of this line, like the example, or make it be false. If is evening, print good evening. And so we can add let calling this and make it false. And then we click compile. Okay, so something is wrong here. Okay, so I forgot the terminal semicolon. And this is some things that will give you errors in your code. So be very aware of this. I need to end this with the colon and then compile. So always pay attention to your error code. That is one great thing I think I love with Cairo. The error messages are so explicit that you know how to handle most of the errors. You click on next and primitive types 2. Still fill in the rest of the line that has code missing. So same as the previous example. So it says a short string is a string whose length is at most 31 characters and therefore can fit into a single field element. Short strings are actually felt. They are not a real string. Note the hyphen, single hyphen quotes that are used with short strings. Let mutable variable, my first initial, be C. If is alphabetic, reference my first initial. Print. If is alphabetic, referencing my first initial. So what this is explaining is if whatever value is stored in the variable called my first initial is an alphabet, print alphabetical. Else, if what is stored in my first initial is a number, print numerical. And if it is neither a number or an alphabet, print neither alphabetic nor numeric. And then it says, let's finish this line like the example. What's your favorite short string? Try a letter. And so if it's alphabetic, we're referencing your character. And so we have to call the your character variable and assign it 8. So let's make this a number instead. Since this is an alphabet. Okay, let's try to compile. I think that is all we need to do here. Okay, something's wrong with your code. Reference, fail to compile, error, ref argument must be a mutable variable. So I declared it as an immutable variable, and so this if else statement can't work because it checks if it's an alphabet or if it's a number, and so this has to be mutable for it to have different values assigned to it at different times. And when I click compile, it should compile now. And great, it is compiled. I would love to continue, but I won't because you need to get your hands dirty and become a Cairo master. So with this, I would ask if you have any questions. So I think I've exhausted more than the time. So do we have any questions? Was everything clear to us? Hi guys, are you still with me? Okay. So if we do not have any question, I think Rukhshana, I think I'm done. I think you can take it over from here.
Awesome. Thank you so much. This has been super helpful. I I'm gonna be sharing it with everybody end of day today. So now we can move over to the Telegram group for any office hours, which just means as you play around with your code or if you have any further questions, you can ask them there. So thank you all for attending, and I'll drop that in the link.
Thank you.